Hello and good day, Algebra. We are learning a new form of an equation today, as if you don't have enough to keep track of all of them. Get ready. The purpose of each of these forms, so far we've talked about slope-intercept form, which is y equals mx plus b. We talked about standard form, which is ax plus by equals c. The point of all of these is it gives us different information about the line. Okay, slope-intercept form, which you don't have to write this down if you already know it, but what information does slope-intercept form give us about the line? What does it tell us? Just by looking at the equation, what can we conclude? Ellen?
You get the y-intercept.
You get the y-intercept, and you get the slope. That's why it's called slope-intercept form. Okay. Standard form, we've used it, but we haven't really talked about what it tells us. We have not graphed using x-intercepts and y-intercepts yet. We'll get there. But this is kind of, it tells you what the x-intercept and the y-intercept is of the equation. The third type we're going to work with here is called point-slope form. And it's kind of a doozy. Okay? It looks like this. Y minus y1 equals m, then in parentheses, x minus x1. Woo! Yeah. Not y minus 1, y minus y1. And we've seen the y1 before in our slope formula, right? Like y2 minus y1, x2 minus, it's not a comma. That is a number 1. Y minus y1 equals m times x minus x1. Okay? And similar to slope-intercept form, we've got some like variables here, right? We recognize m. What do you think m represents? It represents the slope.
Y-intercept.
Okay? Represents the slope, just like in slope-intercept form. And that's why it's called point-slope form. Okay? It gives us a slope. Alex? I don't know.
Kind of fun.
Yeah, I don't know. The other piece of this, we've got that slope part, but the point, okay? You'll notice that we have two y variables and two x variables here, right? We got y and y1 and x x1. Just like in slope-intercept form, your y and your x, I'll underline these in red to kind of just differentiate them from the others. What they represent, the y variable represents the y value of any ordered pair on the line.
Don't we write this down?
You do write this down.
Earlier though this year, didn't we?
We did when we talked about slope-intercept form, which is why I'm connecting this back to slope-intercept form. Okay? The y variable in point-slope form represents the y value of any ordered pair that's on the line. The x variable represents the x value of any ordered pair on the line. Okay? Where y1 and x1 come into play, and I'll underline these in blue to kind of differentiate here. The y1 represents the y value of a specific ordered pair on the line. Okay? So the difference between y and y1 is that any ordered pair that's on the line can be plugged in for y. Y1, though, has to be a specific point. A specific point. That's why it's called point-slope form. It gives you a point, and it gives you the slope. And then x1 would, of course, be the x value of a specific ordered pair on the line. Exciting, huh?
No.
Oh.
Yes.
Thank you. So, what does this form tell us about the graph of the line? What does it give us? It gives us a specific ordered pair. And it gives us the slope. which because it gives us a point and it gives us a slope, we can graph from point slope form, similar to how we can graph from slope-intercept form. Only the difference is in slope-intercept form, you're starting at the y-intercept. In point slope form, you're starting from some other point. Okay? Questions so far? No? All right, let's practice this. Okay? No? Are people still ready?
No.
Oh, you just don't want to practice?
Yeah.
Oh,
Yeah.
oh, gotcha. Okay.
I think we can.
I
Actually, we can practice for a while and like
I
don't give us homework.
There is no.
So it says, write the equation of the line described in point slope form. For the three on the bottom, show how you calculate the slope. So just as a reminder, you can see it on your page, but I'll write it up here as well. Okay. Here's point slope form. If I ask you to write the equation of this line in point slope form, it's got a slope of 7, and it passes through 6, 4. We know what variable of slope is, right? M.
Yeah.
What do you think we're plugging 6 and 4 in the equation, Catherine? X1 and Y1. How do you know it's X1 and Y1 and not X and Y?
Because it's specific.
Because it's a specific ordered pair. Excellent. Okay, it passes through that point. So our equation would be Y minus 4, right? That subtraction sign is part of the formula. Okay, so Y minus 4 equals our slope of 7 times X minus 6. Okay. Y minus 4 equals 7 times X minus 6. Alice.
So negative 4y. Wait, negative 4y.
No, we're done. This is it.
Oh, that's it.
Yeah.
Oh my
It's
god.
in point slope form.
Easy.
Okay.
Guys, it gets harder.
It's gonna get more difficult. It's
Well,
not
I don't know
that
if it
easy.
gets harder. It's just you do more stuff with it.
Yeah,
But
more stuff. Yeah.
if
that's
you're
all.
writing the equation point slope form, this is it. You don't have to go any further. Go ahead.
If you're ever solving this, you have to distribute.
Yes. So if you're then going to a different form, like down here, I give it to you in point slope form, and I have you put it in slope-intercept form. You
Why
would need to distribute and do all that stuff. We'll talk about that. A slope of 1/3, it passes through -2, 1. Our slope, of course, that 1/3, that m. And because it passes through that specific point, -2, 1, this is going to be our x1 and our y1. What's going to be different about this one compared to the last one, though?
Add.
What do you have to watch out for?
You have
Claire?
The negative two is negative, so it would be a positive.
Yes, just like in our slope formula, we've seen this interaction before here. Y minus y1 will be y minus 1 equals our slope, which is 1/3. But then here, when we put that x minus a -2 actually ends up being x plus 2. Okay? So just like in that slope formula, when you subtract a negative number, that subtraction sign is part of the formula. When your ordered pair value is negative, it actually ends up to be addition. Okay? Try the last one on your own, just for funsies here. Try the third one on your own, just for funsies. Okay? I'm gonna take a drink of my V8 Energy, who is not sponsoring this video, but I would accept it if they wanted to. I only have like 4 a day. Okay. What'd you come up with? Jack, what'd you get?
I got y plus 4 plus -5 times parentheses x plus 8.
Excellent. Okay. Excellent.
You're a legend, man.
The slope of -5, you plugged it in for m.
So smart.
Folks, Damien, I need you up here. Since both of our ordered pair values are negative, it's going to be addition in the equation for each one. Y plus 4 equals -5 times x plus 8. The bottom three, what's your only extra step? Your only extra step here. Kylie?
You have to find the slope.
Damien, warning for you. That's a second. You have to find the slope first. Okay? And you do that by using the slope formula. So we can label these x1, y1, x2, and y2. We plug those in the slope formula now. 4 minus 6 over 9 minus 3. 4 minus 6 is negative 2. 9 minus 3 is 6. And we would reduce that to be negative 1/3. Okay? That's why the slope formula was a PO in your previous unit, right? Because we'll be using it again and again and again. Yes, Kylie.
For plugging it into the equation, does it matter which pen you use?
Isn't it great that it does not matter which word you use? Either one will work, okay? So if you decide to use 3, 6 as your ordered pair, your answer would be y minus 6 equals negative 1/3 times x minus 3. If you prefer 9 and 4, you're a fan of perfect squares, and you see that 9 and 4 are both perfect squares, and that, makes you feel good. Then your answer would be y minus 4 equals negative 1/3 times x minus 9. Okay.
I see.
Both answers would be correct because if you were to convert this into slope-intercept form, it would end up being the same thing. And we'll practice that down here, right? But both answers would be fine there. Questions on anything we've done so far? All right, let's talk about one of the bottom four. Pick one which looks particularly intriguing to you. Alex.
Either the second one or the last.
Well, the choice is yours, man. I don't really care.
The last one.
Which one? The last one? Okay. Y plus 2 equals 9/4 times x plus 8. Your job is to put this into slope-intercept form, which someone asked earlier, do we need to then distribute? Yes. Okay, slope-intercept form is the y variable by itself. We've got to get rid of those parentheses. So your first step, distribute in that 9/4. And we get 9 plus 2, or y plus 2, equals 9/4 x. And what's 9/4 plus, or 9/4 times 8? All right, so we'll say 72/4. What does that reduce to be?
18.
18? Okay. And look how close we are now to slope-intercept form. What's our only other step here? Matt?
U minus 2 from the y plus 2 side and put on the other side.
Subtract 2 from both sides. That gets y by itself. And we get y equals 9/4 x plus 16. Slope-intercept form. So it's not a whole big process to convert from one to the other. It's more difficult to get from slope-intercept form to point slope form than it is to get from point slope form to slope-intercept form. But your two steps, you just distribute
It'll come up to it.
and then move your constant over. Okay? Distribute, move your constant over. Arlene.
Could you also for the slope-intercept form 9/4 and then plug in y and x 2 and 8?
Arlene's asking, could you also go the route of, kind of starting with slope-intercept form? You know the slope for each of them is going to be 9/4 because they share that. So she's asking, could you plug in 9/4 for M? And because we know that 8 and 2 is an ordered pair on the line, couldn't we just take those values and plug them in to slope-intercept? I'm going to have to do all this over again. Plug them into slope-intercept form and get the y-intercept that way. What do you think? In theory, should that work?
Yeah.
Yes. But what are you wrong?
Yes.
So to answer your question, yes, you can do that, but you have to be careful because the way I set this up here is incorrect. And we'll talk about why after I answer this important phone call.
No.
Yellow. Religion has them. Joe's room, yes. Yep. Bye. Joseph. Okay. So what did I do wrong in plugging those? Because in theory, yes, you can do that to get the y-intercept, but how did I set this up incorrectly? We're actually going to get more into this tomorrow when we start to graph them, but just as a preview here, I use the ordered pair 8, 2 to plug into 2 equals 9/4 times 8 plus b. Is that the right ordered pair?
No.
Kylie?
Because when you distribute the 9/4 to the x and the 8, you have to simplify that to 18.
Okay, which we did here, right? But 8, 2 isn't actually the ordered pair that this equation tells us is on the line. And this is, like I said, we'll get into more of this tomorrow, but just as a preview here, what ordered pair is this equation telling us is on the line? If it's y plus 2 equals 9/4 times x plus 8. Christopher?
It's -8, -2.
The actual ordered pair is a -8 and a -2, right? Because to get the addition sign here, what does that 8 have to be? It's got to be negative, right? To get the addition sign, it's got to be negative. So, don't worry about that today, okay? But to answer Arlene's question, you could do it that way, but you've got to make sure you're plugging in the correct ordered pair. It should be -8 and -2, okay? But very, very good alternate thought there. Your homework is to finish this page for tomorrow. Make sure work is shown. It is expected.
I did.
It is expected. It is required. Okay. Questions, comments, concerns? Vince, Will, warnings for each of you. I'm not done yet, and you're yelling. Questions, comments, concerns, complaints, comments, congratulations, criticisms. Yes, Alex. In 15 years of teaching, I can't say I've seen enough evidence to support that. I've had very intelligent students with great handwriting and very intelligent students with very poor handwriting. That's what I meant.